Hello, so in this video I'm going to be talking about distillation, simple distillation, fractional distillation, and some general chemistry to, further understand it. So first we're going to understand how molar fractions are made, and it's pretty much, how do we know that we go from having a 50% mole of benzene to suddenly having 80% mole of benzene after one simple distillation. And it requires these three laws, so it requires Raoult's law, Dalton's law, and ideal gas law. So in summary, Raoult's law pretty much gives us the partial pressure from the pure vapor pressure of the molecule with the mole fraction in the mix. So let's say it could be 50%, and the vapor pure pressure, it's usually given to us. Next is Dalton's law that tells us the total pressure is the sum of the partial pressures in the mixture. So that's very simple. The next is ideal gas law. We don't really need to go too in depth right now about how we derive this, but we pretty much find from the general equation that we get the partial pressure of some kind of molecule like benzene, and divided by the total pressure gives us the mole fraction. Okay, so with the goal in mind is with these three equations, we can find the mole percentage, as I said earlier, from converting the liquid to the vapor. So how do we get from liquid to vapor? So we use a technique called distillation, and pretty much how it works is you're gonna have two liquids, they're miscible, so it's a homogeneous mixture. Let's say it's benzene and toluene, and they both have different boiling points. So you're gonna boil the mixture in this flask, and what you want is, or theoretically, the benzene to go up due to vaporization. And what happens is, because cold water is being put here, the vapor is actually going to condensate, so it's going to turn into liquid, and it's going to go down into here, and this is the distillation flask. So in theory we could get two different separations, and we could see that here in a liquid vapor composition plot. And so as we can see, the top is vapor because vapor has a higher temperature than liquid. And what happens is we're going to first start, let's say, with 50% mole of benzene. So I'm going to put 50% mole of benzene. And what happens is, so first we're going to raise the temperature high enough to its boiling point or boiling range, and it's going to start to go up, and it's going to be obviously in its liquid range. And what it's going to do is it's going to go transfer to the vapor, which is obviously higher. And then as we can see, once it condensates, so it goes back from vapor to the liquid line, we can see we get 80% more. And so to provide better understanding of this, I'm going to be using this example using the three equations. So first we're going to use Raoult's law, then Dalton's law, then ideal gas law. And a good way I like to remember it is it's RDI, and it's RDI as in like ready. And a good way I like to think about it is ready to start mole extractions, and the RDI should help you. So first we're going to start with the Raoult's law, and pretty much it's giving us the partial pressure of benzene given the pure vapor pressure of benzene with the mole fraction. So we can fill this in. This is mole fraction. We can fill this in with the pure vapor pressure. And if we look it up, we're going to find that the pure vapor pressure of benzene is 1,200 torrs. So if we quickly do this equation, it's 1,200 times 50%, and that gives us 600 torr. We're going to also do that with toluene. So the pure vapor pressure is 300 torr, so we're going to do 300 times 50%, and it gives us 150 torr. Now, with these two partial pressures in mind, we're going to use Dalton's law. And Dalton's law pretty much tells us that the total pressure is given from the sum of the partial pressures in the mixture. So we're going to just, really quickly plug that in, and we're going to find 600 torr plus 150 torr gives us 750 torr. And finally, we're going to use these two equations into the ideal gas law. And so just give you a quick summary from PV and RT. If we were to put the gas constant, on one side, we can find that P benzene over the mole of benzene equals the the total pressure divided by the total mole. And so, pretty much the main point is that we can find the mole fraction of, a given compound. Let's say benzene gives us the partial pressure of benzene divided by the total pressure. So we're going to quickly put that into equation. And so we knew the partial pressure for benzene was 600 torr, and we knew the total pressure, given from the Dalton's law over 750 torr, and we're going to get 0.8, and obviously we're going to times it by 100%. We're going to get 80% benzene. So if we look into a liquid vapor composition plot, we could see again that after putting it through simple distillation, we're going to get 50%, and then it's going to go to vapor, and it's going to condensate back in the condensation tube, and we're going to get 80%. But obviously 80% isn't a very good yield, and we want to reach 100%. So how do we do that? And we're actually going to do that using a fractional distillation technique. And so in a fraction distillation technique, pretty much what this long tube is called the fractionating column, and pretty much it has many beads around it in a single flask. So what's going to happen is that as you're boiling it and it becomes vapor, the vapor is going to become in contact with all these beads. And so it's actually going to condensate on these beads. And so what happens is you're going to get this 80% mix while it's still in the tube. And obviously it's going to vaporize again, and it might hit one of these beads again, and it's going to hit one of these beads again, and it's just going to constantly go through vaporization and condensation. That's the point. And this graph really demonstrates it, because let's say after that simple distillation, it's only 80%. But with the fractionating column, it's going to actually condensate while still being in the fractionating column. So it's going to hit and it's going to be 80%, and then it might return into vaporization form. And what happens is we're going to get 97%. So in theory, with this fractionating column, we could, go through condensation and vaporization multiple times to achieve a near 100% yield. And so the purpose of fractionating distillation is to perform multiple vaporizations and condensations. I hope that video was helpful, and thank you.